Let's take a look at the concept of net present value. Net present value, or NPV, is a capital budgeting technique for deciding on whether a project is desirable or not. So when a company undertakes a project, for example, Ford is working on the driverless car, how do you decide whether that is a good project to pursue or not? Well, you can use the technique of net present value. And in fact, there are several capital budgeting techniques, but net present value is actually the best. How does this work? Well, what we do is we forecast the future cash flows, and those cash flows are going to be received in different time periods. And the concept of time value of money tells us we can't just add up all the money and compare it to the cost. We need to take the present value of those cash flows. So there are a couple of ways you'll see this written. All right, so we want to find the present value of all the cash flows, and then we sum them up. So in this first equation here, I have NPV equals the cash flows, the present value cash flow equation goes from little t equals 1 to big T. Little t is just a counter for each year, for example. Big T is the final year. So let's say this project's supposed to last for 10 years. This counter is going to go from year 1 to year 10. So you're going to take the present value. This is a present value equation. You'll substitute 1 in here. That would give you the present value of year 1's cash flow. And then you change the counter to 2, and you take the present value of year 2's cash flow, etc., all the way up to year 10, and then you'd subtract out the cost. So this formulation basically starts with the cash flows you're receiving from the project and then subtracts out the cost. Sometimes you'll see the equation written this way, and the only difference is that we begin at t equals 0. Time period 0 is generally assumed to be the time or the cost of the project. So that cash flow is, paid, when you're buying the project or when you're starting the project. So at t equals 0, you're going to have today's time period, right? Because 1 plus r raised to the 0 power is just 1. And cash flow 0 is going to be the cost. And that's going to be a negative number. So both of these are equivalent formulas. They're just written in slightly different ways. So what's the decision rule? The decision rule is relatively simple. Intuitively, we're finding the present value of the future cash flows, and then we're subtracting or netting out the cost. And what's the decision? If NPV is greater than 0, the present value of the cash flows exceeds the cost, and so therefore it's a good project. We should accept it. If the net present value is less than 0, the present value of the cash flows is less than the cost, and therefore you're losing money, so we should reject the project. And if NPV equals 0, the present value of the cash flows exactly equals the cost, and so you're indifferent. That is, you're not making more than you should, but you're not making less than you should. You're getting a fair rate of return. So if you do it, it doesn't add value to the company, but it also doesn't hurt the company. So a positive NPV means you're earning a return that exceeds the cost of capital. The cost of capital being the cost of financing the project. And a negative NPV would mean you're earning less than the cost of capital. So if you're earning 10% and the project is only returning 6%, you don't have to have an MBA to know that that doesn't sound like a good project. You're losing money. All right, so let's look at an example. So here I have a project where it costs $60,000. The first year's cash flows are $30,000. We'll look over here. This is a little easier to see than this small table. The second year's cash flow is $10,000. Third year's is $20,000. And the fourth year's is $50,000. So we can't just add these numbers up. We can't add 30 plus 10 plus 20 plus 50 and compare it to 60. We need to bring all of these back to the present. So we have to bring back the 30,000 back 1 year, the 10,000 back 2 years, the 20,000 back 3 years, and the 50,000 back 4 years. So you're going to compute NPV by looking at these present values here. So 30,000 divided by 1.12 is the present value of the first period's cash flows. 10,000 divided by 1.12 squared is the second period's. And you do it for all four cash flows, then you subtract out the cost. And if you do it, this first present value will be 26,785.71. The second cash flow's present value will be 7,971.94, etc. Okay. Once you sum these up and subtract the cost, you get a project or an NPV of 20,769.19, which is greater than zero, so you should accept the project. That's how much this project will increase the value of the firm. You'll notice that this is a little bit tedious because you have to do each calculation separately. So one way to do this that's a little bit better, I've just recreated the table and these numbers here, is to use the cash flow worksheet. And if you have a financial calculator, they all have cash flow worksheets. This happens to be the BA2 Plus professional model. There's a button here, CF, and you'll notice it says CF0. It's asking for the cash flow in time period 0, and this is going to be 60,000. So let's type in 60,000, change the sign to negative 60,000. You have to enter so that you see the equal sign here, and then we can scroll down. The second cash flow, or the cash flow in year 1, as done by this symbol here, C01, is going to be 30,000. And again, you have to hit enter, down arrow key. This F01 says, what's the frequency of that? If this appeared 3 or 4 times, instead of typing it in three times, for example, we could just type it in once and say the frequency was 3. It only appears once, so let's leave the frequency at 1. The next cash flow in year 2 is 10,000. So again, enter, down arrow. Again, it only appears once, so we'll leave frequency at 1. The year 3 cash flow is 20,000. And again, it only appears once. And the final cash flow is 50,000. Enter. All right, now you hit NPV, and it's going to ask you for an interest rate. We've been using an interest rate here of 12%. So I'm going to put in 12. In the calculator, you put in a whole number. Make sure you hit the enter key so you see the equal sign. Hit the down arrow key and hit compute, and we get 20,769.16. So again, you get the same calculation, a little bit easier because you don't have to calculate each one of these separately and then add them up and then subtract out the cost. And let me note one more way to do it. You can do this in Excel, in any spreadsheet. So there are spreadsheets like OpenOffice and LibreOffice, and they have a built-in function that's an NPV function. Okay. The problem is that the function doesn't actually compute NPV. The programmer who did the first version of this made a mistake in Excel, and to keep past versions compatible, it's never been corrected. So what the program actually does, and this is the way you put in the function into Excel, you put equals NPV, and then if you put a parenthesis, it will tell you what to put. The first thing you put in is the rate, and then you put in the values of each cash flow. Okay, you could actually type in the numbers, or if you happen to have them in a row or a column, you could tell it to go from, for example, cell A4 to cell A10, with a colon. This function assumes that the first cash flow is in year 1 rather than in year 0. So it's computing the present value of the cash flows of the project, not really net present value. So the first cash flow you put in should be the year 1 cash flow, okay, not the cost. So it's really doing it this way, okay? It's discounting this, and then you should subtract out the cost. So you want to do that separately in the spreadsheet when you put it in. So if you happen to have all the data in a column, okay, year 0, year 1, year 2, year 3, going down the rows, you want to skip the year 0 time period, use the NPV function to find the present value of the cash flows from year one to the final year, and then subtract out the cost. So be a little bit careful if you're using Excel. I didn't bother to call up the Excel spreadsheet in this example because it's just too many windows to open up. It makes it a little bit too messy. But you want to be careful about that, and all the textbooks remind you that that's what they do.